Welcome back, students. This is another top prioritized crucial topic, mole concept under basic concepts of chemistry. Let us find out what is 1 mole of any substance. 1 mole of any substance will have an Avogadro number of particles. The particle here can either be an atom or a molecule or an ion. So if you are calculating or if you are counting the number of particles in 1 mole of any substance, that correspond to 6.022 into 10 power 23. And 1 mole of any substance weighs its molar mass. Say for example, 1 mole of nitrogen atom, mass of it will be 14 gram per mole. And the 1 mole of nitrogen molecule, N2 molecule, its mass will be 22 gram per mole. So 1 mole of any substance, it weighs its molar mass. And 1 mole of any substance which is in the gaseous state occupies the volume of its molar volume, and that is 22.4 liter. So the volume occupied by 1 mole of any gas at STP, at standard temperature and pressure, will be its molar volume, and that corresponds to 22.4 liters. Okay children, let us now solve the numericals related to mole concept. You could find the relationship on the board. We are going to make use of this relationship and do the numerical. So the question here is calculate the mass of 60 liter of ammonia. So the mass of 60 liter of ammonia to calculate, let us make use of mole concept. See, 1 mole of the substance, if volume is given, it is volume of given gas divided by 22.4. So the volume here given here is 60 liter, divided by 22.4 gives us the number of moles, and then the moles what is obtained can be converted to mass by multiplying with molar mass. So let us now calculate the number of moles of ammonia. Number of moles of NH3 is equal to 60 divided by 22.4, and if you divide, you will be getting it as 2.6 moles. Okay, so 60 liter of ammonia will be containing 2.6 moles of it. Now, to calculate the mass, we are supposed to calculate the mass. As we know the moles, it can be converted to mass by multiplying with molar mass. So, mass of 2.6 mole of ammonia NH3 will be equal to 2.6 multiplied with its molar mass, where 14 plus 3 which is 17 gram per mole. So 17 gram per mole, if you multiply, here it is 2.6 mole, 17 gram per mole. Mole will get cancelled. 2.6 into 17 will be the mass of it, which is expressed in grams. That is the mass. Here is another numerical. This is the second one. Calculate the volume of 88 gram of carbon dioxide at STP. So here you are supposed to find the volume where mass of carbon dioxide is given. So we'll see that by using the mass, how to convert it into moles. Okay. So we know that number of mole equal to mass given, which is 88, divided by its molar mass. Given mass by molar mass gives us the number of mole. So it is 88 gram divided by 44 gram per mole. That gives us 2 moles. Okay, 88 gram of carbon dioxide contain 2 moles of it. Now you need to convert this 2 mole, that is to find the volume of 2 moles of carbon dioxide. What is the relationship? Moles to find the volume multiplied by 22.4. So volume occupied by volume of carbon dioxide for 2 moles, that will be equal to 2 into 22.4 liter, and that is equal to 44.8 liters. So it's very simple to calculate by using the relationship. So this is it. Here is our third numerical, where we are going to calculate the number of molecules present in 1.8 liter of water. So what is this 1.8 liter of water? You can convert that into mass. 1.8 liter of mass correspond to 1800 grams of it, because density of water is 1 gram per ml. So here liter can be converted to milliliter. So 1 milliliter will be 10 power minus 3 liters. So that way you can convert, where 1.8 liter of water correspond to 1800 grams of it. So we'll consider this 1.8 liter as 1800 grams. So how will you calculate the number of moles? Number of moles of water NH2O can be written as given mass 1800 divided by the molar mass of water. H2O, the molar mass is 2 plus 16, which is 18. So 18 gram per mole, 1800 by 18 will be equal to 100. So number of moles of water present in 1800 grams will be equal to 100. Okay. Now the number of molecules. To calculate the number of molecules, what's the formula? Number of molecules equal to number of moles of water multiplied with Avogadro number, which is 6.022 into 10 power 23. You will be able to find the relationship here. You've calculated the number of moles by using the mass. Now you can convert the moles into number of molecules by multiplying with Avogadro number. So NH2O here is equal to 100. So 100 into 6.022 into 10 power 23. These many molecules of carbon dioxide you will be able to find in 1.8 liter of carbon dioxide.